Okay guys, now I want to discuss about the types of roots. So different discriminants can talk about the behavior of the roots. So this table discusses about as the discriminant changes, what happens to the actual roots of a quadratic function. So first of all, a root can be either real or imaginary, okay? Real numbers are any numbers that we can have in our life. 2, 10, -5, -0.6, anything like this are real. But imaginary numbers are those that can't actually happen or are undefined, okay? So numbers like square root of a negative number, say square root of a -5. Remember how I told you we cannot square root a negative value, otherwise it will be undefined? So therefore, those numbers represent imaginary numbers, numbers that don't happen in our everyday lives, okay? So now, first of all, discuss about 3 cases of the discriminant. Now these are not all the cases, but these are our main cases that I want to discuss in more depth. So b squared minus 4ac, which is our discriminant, if it's a square numbers are like 1, 4, 9, 16, 25. These numbers that can be rooted perfectly, okay? So square numbers are definitely going to be real if we square root it, right? Because the root is the actual root of the quadratic function, and that root, if we put it into our quadratic formula, minus b plus minus root b squared minus 4ac over 2a, if we put a square number into that square root, we're going to have rational solution for the root, okay? So the square number will give us a rational number because square root of, say, 16 is perfectly just 4, okay? And we're going to end up with 2 solutions that are rational, okay? So if you see a square number as a discriminant, you can determine that it's real, so therefore it's going to be rational, all right? Out of the real numbers, it's going to be a rational number. Okay, so think about the roots after you've decided the discriminant. So now let's go into the zero discriminant. Let's say discriminant is becomes 0. If it's 0, the whole root or the whole solution becomes equal. Now what does it mean by being equal? Now if we have a 0 inside our square root, okay, we're going to remember how I said in our first section that if discriminant equals to 0, we only have one solution. That's because negative b plus root 0 is the same as negative b minus root 0. So because negative b plus 0 is the same as negative b minus 0, the roots are equal. Okay, so therefore, if the discriminant is 0, that's why it's going to have equal solutions. So therefore, only one solution. Okay, that's why. So if you see a 0 discriminant, just say it's equal. Now, if we have a negative discriminant, let's say b squared minus 4ac is negative, a negative solution, then, well, can we square root a negative value, guys? No. So therefore, we're not going to have any solutions. Therefore, the root will be imaginary. Okay, we're not going to have any roots at all because we cannot square root a negative number. Okay, so the root just becomes imaginary, and that's it for the negative one. Okay, so these are some main parts to finding roots and different types of roots. So please remember these 3 because they come out a lot. Okay, so let's have a look at the other questions. So starting with question 3, find the discriminant and tick the appropriate boxes. Okay, well it's telling us to tick the appropriate boxes first by finding our discriminant b squared minus 4ac. Well here, a is 1, b is -1, c is -4, isn't it? So if we do b squared, which is -1 squared, which is just 1, minus 4ac, 4 times 1 times -4. Okay, so because it's minus, it's going to be -4 times 1 times -4, which will be positive 16, so it will be plus 16. Our discriminant is simply 17, okay? I'm just going to put it in my discriminant box over there. Okay, so this is our discriminant, we've got 17. Now, we've found the discriminant, let's discuss the type of root it is. Okay, hope you guys know that if we square root that 17, it's going to be a real number, right? Because it's not negative, it's not going to be imaginary. So it's going to be out of our real columns. Now 17. Well, remember how if it wants to have equal roots, the discriminant must be equal to 0, but since 17 is not equal to 0, okay, negative b plus root 17 is going to be different to negative b minus root 17, so therefore it's going to have unequal roots first of all. Okay, the two roots are going to be distinct with each other, they're going to be different. Now, root 17, is that a rational number or irrational number? Okay, rational numbers are numbers that are quite perfect, aren't they? Like 2, 4, root 4, okay? But irrational numbers are like pi, okay? Or root 2, root 7. So therefore, root 17 is also irrational, okay? So root 7, if you have b squared minus 4ac as 17, the two outcomes of the roots are going to be unequal and irrational. So these are the properties of the roots and type of root it is. Okay, so that's our first one. Okay, question 3a. Have a look so we can move on. Okay, let's go on to b. This time it's 2x squared plus 3x plus c. Okay, this time let's first find the discriminant. That is a, that is b, that is c. Okay, 2 is a, 3 is b, 6 is c. So therefore, if I want to find the discriminant, which I like to make a notation of this triangle, is b squared, which is 3 squared, which is going to be 9, minus 4 times 2 times 6, because it's 4ac, isn't it? Now 4 times 2 times 6, 8 times 6 is 48, so 9 minus 48 would just be negative 39. Okay, so that's our discriminant, okay, that I just obtained from here. Now, negative solution, we've got a negative discriminant. If we square root a negative number, what happens? The number is just imaginary, and that's it, okay? It's not going to be a real number, it's going to be imaginary. Okay, so we'll have no roots at all. Okay, that's when it's imaginary. Hope that makes sense. And that's it for the negative discriminant. Okay, so quite straightforward, wasn't it? Okay, so always when you see negative discriminant, immediately say it's imaginary, or you could say unreal if you like, okay? Some schools refer to it as unreal numbers. Okay, that's question 3b. Let's go on to c. c, x squared minus 9x plus 20. Okay, let's find our discriminant again. Negative 9 squared, okay, b squared is going to be negative 9 squared, minus 4 times, a is 1, and then c is 20. Okay, negative 9 squared is positive 81. 4 times 1 is 4 times 20 is 80. So 81 minus 80 is simply 1, isn't it? So we've got our discriminant as 1. Now 1, always think about the square root of the discriminant. Square root of 1 is 1, so therefore it's a real number. It's not going to be imaginary since it's not negative. So it's going to be out of these columns. Okay, now if it's 1, is it going to be equal or unequal? Well, it's not equal to 0, so it can't be equal, because negative b plus root 1 is different to negative b minus root 1. So therefore it's unequal first of all. Okay, the two roots are going to be unequal. Now, think about if it's rational or irrational. Root 1 is a rational number, isn't it? So the whole solution will be rational, okay, since the discriminant is rational. So therefore, the two solutions or two types of roots this kind of function can have is unreal roots and rational roots, which are real roots. Okay, so have a look at those. And always think about the square root of the discriminant to determine the roots, okay? That's question 3c. Let's move on to d. d is x squared plus 4x plus 4 equal to 0. Again, let's look for our discriminant by going b squared. b is 4, so I'm going to do 4 squared minus 4ac. So minus 4 times a is 1, c is 4. Okay, now 4 squared is 16 minus 4 times 1 times 4 is 4 times 4 basically, so 16. So 16 minus 16 is 0. So we have a discriminant of 0, don't we? Guys, if we have discriminant of 0, square root of 0 is 0, so it's not going to be imaginary, it's going to be real. So out of these 4 columns, if it's 0, guys, it's going to be equal. Okay, and that's it. Because root negative b plus root 0 is the same as negative b minus root 0, isn't it? So therefore the two roots we can have are going to be equal to each other, therefore it's just equal. Okay, so that's when you have discriminant equals to 0. Okay, so I hope this is quite straightforward now. I hope you're getting the hang of this. Okay, now question 3e is 2x squared minus 5x minus 1. Okay, again we're going to look for our discriminant. B squared, negative 5 squared, isn't it? B is negative 5, so I'm going to go negative 5 squared minus 4. A, which is 2. C, which is negative 1. Okay. Negative 5 squared is 25, positive 25. 4 times 2 is 8. Times negative 1 is negative 8. But timesing a negative again makes positive 8. So what's 25 plus 8? Simply 33. So our discriminant is 33. Okay. Now square root of 33. Because 33 is not a negative number, it will not be imaginary, but it will be real. Okay, so it's going to be a real root, and we're going to choose out of these columns. Okay, root 33 is firstly going to be unequal, because negative b plus root 33 is different to negative b minus root 33. Okay, so it's going to be unequal. Now, is it going to be rational or irrational? Rational or irrational? Now, if you root 33, what's the outcome going to be? It's not going to be a perfect square, is it? So therefore this one is irrational. Okay? So it's irrational number because it's not going to have a perfect square. So the two outcomes, or the two types of roots we can say the discriminant of 33 can have is unequal roots and irrational roots. Alright? That was question 3e. Now F says negative 2 plus negative x squared plus 2x minus 5 equal to 0. Okay, now let's again find our discriminant. Equals to b squared, which is 2. So 2 squared minus 4 times a, which is negative 1, times c, which is negative 5. Okay, let's simplify this. 2 squared is 4. Now, negative 4 times negative 1 is positive 4, but times negative 5 is negative 20, isn't it? So 4 minus 20 is going to be negative 16. Okay guys, there's a negative discriminant. What happens if we square root a negative number? It becomes undefined, so therefore that's the solution, or the roots for the discriminant with a negative 16 is going to be imaginary. Okay, I hope you guys can just tell that it's imaginary if you see a negative discriminant like that. Okay, that's question 3F. Okay, so you can do it now, right? Negative discriminant always going to be imaginary. We cannot square root a negative value. Okay, that was question 3F. Let's move on. G says x squared minus 2x minus 3 equal to 0. Okay, again, find our usual discriminant. B is negative 2, so negative 2 squared minus 4 times A, which is 1, times C, which is negative 3. Okay, so negative 2 squared is positive 4, right? 4 times 1 is 4, times negative 3 is negative 12, but with that negative at the front as well, it will be positive 12. So 4 plus 12 is 16, right? So we have a discriminant of positive 16. It's a positive discriminant, so it's not going to be imaginary, it's going to be real. Okay, so let's choose our columns. So if it's 16, okay, is it going to have equal or unequal roots? Now, negative b plus root 16 is going to be different to negative b minus root 16. So first of all, it's going to be unequal. The two roots are going to be distinct. Now, is it rational or irrational? If we square root 16, what's the outcome? It's 4, isn't it? So it's a perfect square, so therefore it's rational. Okay, so that was pretty simple, I hope. Question 3G, the roots are going to be unequal and they're also going to be rational roots. Okay, that's question 3G. Alright, H, negative x squared plus 1 equals to 0. And guys, for those who are a little bit confused, I'll write this again as negative 9x squared plus 0x plus 1 equals to 0. Okay, I added that extra 0x in there for you, so I can have the x squared, then x, and then the constant. Okay, so you can write it like that if you want to, and then therefore a is negative 9, b is 0, c is 1. So therefore our discriminant is going to be b squared, is going to be 0 squared. 0 squared is just 0, so I'll just write it like that, minus 4 times a, which is negative 9, and then c, which is 1. Okay, so negative 4 times negative 9, okay, is positive 36, times 1 is still 36, plus 0 is still 36, so our discriminant is 36. Okay, so our discriminant, we have positive 36, it's a positive number, so it's not going to be imaginary, it's going to be a real number. Okay, root 36, okay, negative b plus root 36 is different to negative b minus root 36, so therefore it's going to have unequal roots. Okay, so I hope you guys know by now that if it's not 0, it's always going to be unequal roots. It's always going to have two distinct solutions or roots. Okay, so we've got unequal roots. Now is it going to be rational or irrational? What's root 36, guys? Root 36 is perfectly 6, isn't it? It's a perfect solution, so therefore it's going to be a rational solution. Okay, so our two types of roots that we can call a function or quadratic function with discriminant of 36 is going to be unequal and rational. Hope you are really getting familiar with this now. Okay, make sure you know the meaning of each. Okay, hope you do know that by now. That was question 3H. Okay, let's go on to question 4 now. So hope you are good at those equal, unequal, rational, irrational, real or imaginary. Okay, so hope you can tell the difference between each one. Alright, because a lot of your exam questions will ask you to tell the different types of quadratics the roots will have. Okay, so please know that carefully, because now let's go on to question 4. This is a little bit of a different type of question, but it's still regarding roots. So it says find the values of a for which the equation 5x squared minus 2x plus a equals to 0 has real roots. Okay, the roots of this quadratic equation will have real roots, but see how a is unknown? Okay, we have a pronumeral for the constant number, so we have to go ahead and find that number. So if it has real roots, guys, it's not imaginary roots, right? Real roots means any particular number that can work or we can use, but imaginary numbers are numbers that are undefined, right? So for this, okay, to have real roots, the discriminant must be greater or equal to 0. It can be equal to 0 because 0 is still a real number. So b squared minus 4ac, the discriminant will be positive or equal to 0. So I'm just going to write it like that first because I just applied my property. Now, b is negative 2, a is 5, c is a. So therefore, I'm just going to solve my values in, like that. Okay, b is negative 2, so we have negative 2 squared minus 4 times a, which is 5, and therefore a constant number c is going to be a. Alright, and that's again still greater or equal to 0. Yep, simplify it like this. Negative 2 squared is positive 4, negative 4 times 5 is negative 20, a. Okay, it's still greater or equal to 0. Solve for a, guys. Okay, a is simply 0.2. Okay, a is simply less than or equal to 0.2, sorry. Okay, if you want to do some more working, basically, I'm just going to move my 4 over to the other side. So I have negative 20a is greater or equal to negative 4, right? And if I divide both sides by negative 20, and guys, remember, if I'm dividing or multiplying by a negative number, we must switch the signs around. So a is simply going to be, I switch the sign around, 4 over 20, which is going to be 1 over 5. 1 over 5 is the same as 0.2 as a decimal. So therefore, the values of a for which this function has real roots is when a is less than or equal to 0.2. And that's it. Okay, so when you get to a question like this, guys, think about the property of real roots, because this one they ask for real roots. But if they say imaginary roots or unreal roots, think about what you're going to do. We'll get to one of those later. Okay, always think about the property, and then just after that, it's basically all just algebra, as you can see. Okay, so that was question 4. Have a look. So we'll move on. Question 5 says, find the values of a for which the equation x squared plus 2ax plus 1 equals to 0 has equal roots. Okay, if it's equal roots, what were equal roots, guys? Well, you know how the quadratic formula means negative b plus or minus root b squared minus 4ac over 2a? So it's going to have two solutions, positive or negative. But they're asking for when the two solutions are equal to each other, so therefore have only one solution. Remember, guys, equal roots have discriminant of 0, right? Because if it's 0, negative b plus root 0 is the same as negative b minus root 0, isn't it? So the roots are equal, and that only happens if the discriminant is equal to 0. So please remember that. This applies for equal roots, all right? Okay, we're going to do our usual thing now. Sub all your ABCs in. Okay, A is 1, B is 2A, and C is 1. So I'm going to sub it in. B is 2A. Okay, don't just say 2, it's 2A. So I'm going to do 2A squared minus 4AC. 4, negative 4 times AC. A is 1, C is 1, so therefore it's just going to be minus 4. That's equal to 0. Okay, expand and simplify. So see how here, 2a squared, okay, I'll just show you another step here. 2a squared is 4a squared minus 4 equal to 0. So therefore, if I divide, I'll move 4 over to the other side. So I get 4a squared equal to 4. So if I divide both sides by 4, I will get a squared equals to 1, won't I? Okay, I get a squared equals to 1 from this step by dividing both sides by 4. If a squared equals to 1, then basically a is simply plus or minus 1, isn't it? Please don't forget your plus minus sign. So therefore a can be positive 1 or negative 1, and if a is those two values, either a positive 1 or negative 1, the quadratic equation here will have equal roots. Okay, it will have equal roots. So trying to understand that. Okay, and as you can see, after applying the property of equal roots, where discriminant is equal to 0, the rest is just algebra. Okay, so please get the first step correctly. That's question 5. Let's move on. Okay, so question 6 says, find the values of a for which 2x squared plus x plus a plus 1 equals to 0 has two unequal roots. Okay, now the key thing here, guys, is that this function has two unequal roots. So what are the properties of unequal roots, guys? Well, for a function or quadratic function to have unequal roots, the two roots that they obtain must be different from each other. Okay, they must have distinct roots. So therefore, the properties of the discriminant, if it wants to have unequal roots, the discriminant must be greater than 0, right? Okay, I repeated this throughout last few questions as well, but the discriminant must be greater than 0. For example, 10. Okay, negative b plus root 10 divided by 2a is different from negative b minus root 10 divided by 2a, right? So therefore, the discriminant must be greater than 0, must be a positive number to have two unequal distinct roots. Okay, so please remember that. Okay, now have a look at this, guys. Now here, 2 is going to be our a, right, the coefficient of x squared. Now see how this is 1x, so 1 is our b, okay, the coefficient of x. Now, the constant number c is not just going to be 1, guys, it's going to be a plus 1. Okay, a plus 1, the whole thing is c, as you can see. Alright, so please don't get mixed up with that one. So now that we've got our ABC, let's substitute these values into that b squared minus 4ac is greater than 0, just like this. B is 1, so I did 1 squared, which is just 1, minus 4 times a, which is going to be 2, times c, which is a plus 1. Okay, and that's all greater than 0. Now we just need to simplify. So I'm going to simplify down to 1 minus 4 times 2 is 8. So if I want to expand out the brackets, it's going to be 8 times a, which is going to be negative 8a, and negative 8 times positive 1, which is going to be negative 8. And that's greater than 0. So I just expanded out my brackets and simplified it. Okay? And then this will be something like this, wouldn't it? 1 minus 8 is negative 7 minus 8a is greater than 0, right? And then I'll move negative 7 over, so I have 8a left on this side is greater than positive 7, because I'm moving that over. So therefore, to find a is simply less than negative 7 on 8, because if I divide both sides by a negative number, negative 8 in this case, if I'm dividing by a negative number, I must switch my signs around. So I've got to go a is less than negative 7 over 8. Okay? And that's the solutions. So for this function here, this quadratic function, to have two unequal roots, the values of a must be less than negative 7 over 8. Okay? If it's greater than that, it won't have two unequal roots. So it must follow this rule, this restriction here. And that's the answer to question 6. Okay? So that was it. Make sure you remember if the roots of a particular function is going to be real or imaginary. Is it going to be equal, unequal? Okay, is it going to be rational or irrational? You have to know the difference between each of those very well in order to approach these kind of questions. Okay? So that was question 6.